Advanced Medium Combat Aircraft is designed as a single-seat, twin-engine combat aircraft. The AMCA Mark I will come equipped with 5.5 generation technologies, and Mark II will have the incremental 6th generation technology upgrades. The AMCA is intended to perform a multitude of missions including air supremacy, ground strike, suppression of enemy air defenses, and electronic warfare missions. It is intended to supplant the Sukhoi Su-30 MKI air superiority fighter, which forms the backbone of the Indian Air Force's fighter fleet. Certainly, breaking down the video into 4 parts, development, design, operators, and specifications, will help us analyze and understand each aspect more thoroughly. Let's delve into each part. The AMCA, earlier known as the Medium Combat Aircraft Program, is an Indian program to develop a 5th-generation combat aircraft. The AMCA program was launched in 2010, although envisioned as a 20-ton class fighter earlier. Now AMCA is 25-ton class fighter. A feasibility study was launched in October 2010, followed by project definition and preliminary design phase in 2013. From November 2013 to December 2014, 9 design configurations of AMCA, starting from 3B01 to 3B09, were studied using computer-aided design, low-speed high-speed wind tunnel testing, and radar cross-section testing. By the end of 2014, configuration 3B09 was chosen. In 2015, the basic design configuration of AMCA was finalized and has been accepted by Indian Air Force in 2016. The design work was completed in 2023, and approval for the Rs 15,000 crore project for prototype development was received in March 2024. DRDO expects to roll out the first prototype in 3 years by the end of 2027, and the first flight in 1 to 1.5 years after that. Total 5 prototypes are to be built. The IAF planned to procure at least 125 AMCA in Mark I and Mark II configurations. The Mark II of AMCA is expected to have a more powerful engine, 6th-generation features and technologies to stay relevant in the coming decades. In an interview given in 2020, the then Air Force Chief RKS Bhadoria stated that the planning process is already underway for combat systems like optionally manned 6th-generation technologies, smart wingman concept, swarm drones, long persistent high-altitude long-endurance platforms and hypersonic weapons, among others. He also added that it is imperative to incorporate such advanced technologies to keep AMCA relevant. It is also reaffirmed by Indian Air Force's current Chief Vivek Ram Chaudhary. The AMCA would be the first 5th-generation fighter to enter service with the Indian Air Force. The AMCA is designed with shoulder-mounted diamond-shaped trapezoidal wings, a profile with substantial area ruling to reduce drag at transonic speeds, and a stabilator V-tail with large fuselage-mounted tail wing. Flight control surfaces include leading and trailing edge flaps, ailerons, rudders on the canted vertical stabilizers, and all moving tailplanes. These surfaces also serve as air brakes. The cockpit features a single-seat configuration which is placed high, near the air intakes and wings of the aircraft to provide good visibility to the pilot with a single bubble canopy. A leading-edge root extension, LERX, which is a small fillet, is situated on the front section of the intake and wings of the aircraft. It has a typically roughly rectangular shape, running forward from the leading edge of the wing root to a point along the fuselage. The aircraft features a tricycle landing gear configuration. The weapons bay is placed on the underside of the fuselage between the nose and main landing gear. The AMCA is designed to produce a very small radar cross-section. To accomplish this, it features S-shaped air intakes to reduce radar exposure to the fan blade, which increases stealth, uses an internal weapons bay, and features the use of composites and other materials. The flight control surfaces are controlled by a central management computer system. The AMCA will have some 6th-generation characteristics such as an optionally crewed, directed energy weapons, capable of controlling UCAVs and swarm drones. So let's delve a little bit deeper in this topic. The AMCA design has inherent radar stealth, achieved through twin-tail layout, platform edge alignment and serration, body-conformal antenna and low-intercept radar, diverterless supersonic inlet (DSI), with serpentine ducts which conceal engine fan blades, internal weapons bay and extensive use of composites in airframe. According to Jane's Information Services quoting ADA, the airframe of AMCA will have 38 to 40% composite. As of October 2022, designers are still in the process of refining the radar deflection capability of AMCA. It will also use radar-absorbent materials wherever necessary. The AMCA is expected to have distributed passive sensors with artificial intelligence-assisted multi-sensor data fusion to increase situational awareness, and to work in tandem with the Advanced Electronic Warfare Suite onboard AMCA. The AMCA will also have an integrated vehicle health monitoring system, which works on sensor fusion. AMCA will be equipped with a larger and powerful variant of the UTOM AESA radar, which will use gallium nitride technology. It will be mounted on a mechanically steerable mount. An onboard condition monitoring system is also planned to be included in the AMCA. The platform will be equipped with a quadruple digital fly-by-optics control system, using fiber optic cables to reduce weight, increase the rate of data transfer, and reduce electromagnetic interference. The AMCA will have a glass cockpit equipped with a wide panoramic touchscreen display for enhanced man-machine interaction, a multi-function display placed in portrait orientation, and a wide-angle holographic head-up display. The AMCA will have hands-on throttle and stick arrangement with right hand on stick and left hand on throttle settings to ease the pilot workload. The AMCA is to be powered by 2 afterburning turbofan engines. The plan is to equip General Electric F414 afterburning turbofan engine on AMCA Mark I, while a more powerful joint venture engine is planned for AMCA Mark II. The Indian Air Force's plan to induct 7 squadrons of the AMCA in the first phase represents a significant step forward in India's quest for self-reliance in defense production and the modernization of its air force. The AMCA program is poised to enhance India's aerospace capabilities, bolster national security, and contribute to the country's strategic autonomy in the defense sector. It features a crew of 1 and boasts dimensions of approximately 17.6 meters in length, 11.13 meters in wingspan, and 4.5 meters in height, with a wing area of 55 square meters. With an estimated empty weight of 12,000 kilograms and a gross weight of 18,000 kilograms, the AMCA is designed for a maximum takeoff weight of around 25,000 kilograms. It can reach a maximum speed of 2,600 kilometers per hour, or Mach 2.15, enabling rapid response and high-speed maneuverability. The aircraft boasts a range of 3,240 kilometers for standard operations, with a combat range of 1,620 kilometers and a ferry range of 5,324 kilometers.